Okay, we are recording now, so I will start from scratch. I asked Chen to send me a data set. So first I will download this data set. I'm using the extended screen, so you probably won't see what is on this screen, but I'm doing something on the other screen. So you probably won't be able to see something here, but I'm doing something there. Okay. Open the VS Code. You can use a local version. I will use my workstation in my office. Is my on my way? Okay, give it a minute to set up the environment. Okay, to give us a little extra space. I have author data here. So first I will teaching, go to my folder, which I used for teaching. Okay, DII, have a repository specifically for this. Oh, no, wait. So I actually have a template. So what I'm going to do is I will start from a template. So here is a research project template. I make it for all my research because each of you have a different kind of workflow, right? So this template is just for my workflow. I found it very effective. So and also I keep revising it, keep updating it, right? So I will start with this template, git clone this template. See it is there. Okay, yes, it is there. I will rename it network demo. Okay, it is renamed it. I will open this folder, workspace, working, teaching, network demo. Are you okay with seeing this? Or I change it to black and white? Probably change the theme is will work better, right? Let's change a color theme. I used to work long time with this, so it's easier for me to have this as a black and white, high contrast color theme, modern, light modern, light plus. Is that better, or is the dark is better? This better, or this is better? Light is better. Okay, cool. Light modern. Okay, I will use this. Okay. So once I have the template here, I have a lot of stuff, right? I can start with it. So the agents have a lot of agents behavior. And also in the writing, it has some agent writing like a quality control and knowledge base. It has all this, all files, all the stuff, right? So it's not built one day, right? I built it. I use AI a lot in my research as a companion, so I have all this readily available. So and I extract a template and then make the template available on demand. Now I have the data set. What I'm going to do is I will pull this data set to this raw folder, which I won't touch it again, which I won't touch it, right? If you recall the data management chapter, the raw data is something you never want to touch, right? So that's what it is here. Okay, now we have it. So the knowledge base is the place where you want to do the knowledge part. I do have the chapter here, so I'm gonna skip it. I will put it here. So what I'm going to do is stop at the agents here, pen mode. I'm using Claude. You probably are using other kind of AI tools, but they're the same. Just the Claude is more like capable, and it is more expensive as well. So there are pros and cons. OpenAI, I found it is useful, especially if you open the extra high, and also the speed you can use faster speed if you're okay with that. So I found 5.4, yeah, actually very good. So Claude sometimes it is good for writing and UI stuff. It's more nuanced. It gives you better results. But in terms of logic, for example, if you're purely working on some logic or some like these math problems or reasoning stuff, I think my feeling is ChatGPT, the 5.4 is as capable as Claude. So there are not a lot of different. I will start with a plan mode. So in my research, I found most of the time the time I spend most is on planning something, not on writing something, right? So what I'm going to do is first I need to make a plan. Then I will just let it go, right? So I think in the previous like half year before or a year before, what I did is I will write a match script in the first place. So the UI of all these AI tools wasn't designed like this, right? So it is not, it has a plan, but does not have that kind of feedback loop. So, but right now the AI is so capable, you can use it to revise your plan. So I found it is more intuitive and more useful to just use the AI itself, the interface provided by AI itself to do the plan. I will show you how to do that. Be more concrete. I will show you that later. Right now, sorry for the oak pollen. Okay, we have a data set with author info from OpenAlex. I will mention this data. The purpose is construct a network with construct a co-author network with these authors using network X, analyze various centrality values of different authors. 3. So we have a theory part, right? So in the theory, we ask you specifically to link the centrality values to theoretical importance. Connect different centrality values to their practical and theoretical implications. What's next? Values to theoretical implications. Draw some conclusions. Lastly, use open, because the data Chen provided to me is very lean, right? So say here, it's here, it's here. So we only have how many columns? We only have 2 columns. 1, 2, 3, right? We only have 3 columns. Yes, that's there are a lot of things missing here. For example, if we want to construct a co-author relationship, co-author relationship, first we need to know the papers these people publish, right? So that we know how they are co-authoring, right? So, but we don't have the data set here. That's okay. Let's figure it out. Let's see if the AI can figure it out. That's why we want to mention that. Use OpenAlex. How many authors we have here? Oh, that's a lot. That's a lot. We have a data set from OpenAlex. The purpose is, for demonstration purpose, let's just use 10%. Is that okay? Yeah. Use random 10%. Make sure that it is replicable. Set the seed be replicable. Set the random seed be replicable. The purpose, even if it is random, once we set a random seed, every time we run the algorithm again, it will generate the same thing, right? So that's why we want to make sure that the random seed is explicit. Okay. Use OpenAlex API to retrieve more information if necessary. Anything else you want to add into this?
I feel like it's already a lot of tasks to do.
A lot of tasks to do. Yeah.
I don't know if
yeah.
we should add in more information.
Yeah. You see, one thing I'm not doing here is ask the AI to suggest me any references. That's the stuff I never do that, because even the most capable AI, sometimes they hallucinate, right? So I will do that part by myself. So I will provide a list of theoretical important kind of articles for the AI to cite, instead of asking AI give me recommendations about what references to use. Yeah. So that's part is you have to avoid that. Definitely avoid that. Never do that in the workflow. And I don't think that problem will be solved in the near future. It's very, if you think AI as a person, as a human, right? So if a human give you his idea about any references without using a factual database, that person can give you false information as well, right? So no matter how the advanced the AI is, the AI won't be a database. The AI will be an intelligent agent, but it won't be a factual database. That's the key here. So never ask your AI to give you suggestions about references. Okay, let's see how it goes. It will take some time, but it will be very fast usually, because we only have a little information here. So not a lot of information here. So during the time, you can take a rest, see behind. Okay, good. We have so many authors, a 10 sample, roughly about 146 authors. So you see it is reading all these templates here. Yes, it is also reading the API docs. Let's add all projects. So sometimes it is also useful to review, to just see what is going on here, because you want to make sure that the chain or the process is also audible, right, as well, right? So like this, for example, this link, the OpenAlex, they themselves wrote something that is very AI friendly. This is LLM friendly, right? So this is a documentation purely for AI. Good. The project is a fresh scaffold with all needs packages installed. I have all the packages here. No existing code. the author info by author ID with info from the authorship array. Let me assign the implementation plan. Okay, we are about to see the plan. So these are preset templates. If you take like those are preset templates here. Code books, concepts, literature, some empirical methods, theory, memory. So these are based on the chapter 2, the AI framework chapter, the newly added chapter. If you haven't read that, you can take some time to read that chapter. So you see the structure of this folder is specifically rules, memory, and knowledge, rules, memory, knowledge, those three things. The KB is knowledge, the memory is memory, it's very straightforward, and the rules, if you all the agents file, they are the rules. They are the rules. It took some time, right? So yeah, it is working. Excellent. I have a comprehensive understanding of now. Let me write the plan and flag the key decisions points. You see the in my template, I asked the AI, I instruct the AI to flag key decision points. Okay, now we need to make some decisions. How should we define the network boundary? This affects centrality measure meaningfully. Yeah, that's right. Because in network, if we think about the network, everyone is connected to everyone, right? So if you do snowball sampling about the individuals in the network, you can iterate the network indefinitely, right? So which means the network can grow exponentially. So you have to make a decision, say what's the boundary of this network. So usually what we do in research, sometimes there are several boundaries. The first is literature, right? So in the first assignment, you get a literature pool of your data set. So the literature itself is have a set boundary. For example, according to the keyword, you have 1,000 references in your library, in your data set. So that 1,000, you only construct a network with that 1,000 articles, authors, right? So that gives you a very clear boundary. So this is very useful if you have a clearly defined research field, right? So you are very confident that, yes, the key terms I'm using here represent the field. Then it comes to the question that how the terms are used, how the terms are defined and used, right? So that's very key. So if you send paper out for review, the reviewer will see all these terms. You cannot be very broad, because if you go very broad, the substantive contents will be diluted, will become very small proportion, right? But if you go very narrow, you will be missing a lot of information, missing a lot of key critical information. So you have to find a way that give you the most appropriate boundary of the literature you are looking. Author recommending all authors, include all authors found in the sample, sampled authors only, one hop neighbors. So one hot neighbors this is another way to do the sampling. So we have say, okay, now we have 10 authors here. We want to see how many people are linked to these 10 authors, right? Then any authors who have one connection with these 10 authors we are focusing on, they will be in our analysis, they will be in our network, right? So that's kind of a 1 degree. You can also say it is 1 degree. Anyone who has a 1 degree connection with all these authors will include them in our dataset. So include sample authors plus their direct authors, but don't expand it further. For example, who connect to those co-authors won't be included, right? That degree. So these decisions you have to make based on your research question. In my previous research, I used both types of networks. Sometimes I will use the literature bounded network. Sometimes I will use degree bounded network. It really depends on the research question you are answering here. So for this one, which option do you think we should choose? Which option you think we should choose? Come on, AI is helping you so far, so you need to do something, right? Which option do you think we should choose? Go with the recommended, right? Yeah, that's not the rationale here, right? Yeah. Although it's a correct answer, but I don't think that's a good rationale for here. It depends on the research question, right? So the information Chen sent me is already literature bounded, also a literature bounded data set, right? So he extracted all these authors from the literature. So that literature has a clear boundary. So he generated that literature using keywords, filtered keywords, right? So I will just go with these authors, right? So all authors. Oh, wait. So I won't do the all authors. I will do the sampled authors only. Because right now, for the demo, we use 10%. which means we are assuming the 10% is the population. That makes sense? So we won't do the all authors. Because if we choose the all authors, we will mess up with the demo and the real situation. That makes sense? If we use all authors, there must be a reason we are doing a random 10% sample now. But there's no reason. The only reason we choose a sample, the 10%, is just because of the demo. That is not research relevant. That is not research relevant, right? So we have to assume this 10% is the whole, is the kind of entire population here we are studying. That makes sense? So I won't go with all authors, because if you go with all authors, it'll mess up with the 10% and something like else. And you cannot extend. Another caveat is you won't be able to extend your research to a bigger data set. For example, in a later stage, you get a code. You say, okay, now I want to run this on a whole sample instead of just a 10%, right? But your original data set is a mixed analysis of all authors and 10%, right? You won't be able to easily change. But if we just use the 10%, next time if we want to extend to the whole data set, I will say, what I can easily say is, yes, use a whole sample instead of 10%. And then everything will work. You don't have to change anything beyond the sample point, right? That makes sense? Does that make sense? Yeah. So I will use these sample authors only. Okay. What output format do you prefer for this analysis? Jupyter Notebook, it is recommended. Modular Python scripts, other. So which one do you prefer? A single notebook combined with code, narrative, visualization. Usually for social scientists, I found the notebook is more intuitive, right? It's easier because it is block by block, so you can inspect the block. But for some automated process, I usually use script. For example, I have a dedicated script just to retrieve all the information of these authors. So that process is a single, is a very clearly bounded kind of process. I will use script. So usually in my workflow, I will combine Jupyter Notebook and the script. But for this one, we will just use Jupyter Notebook. Because right now it is not that complicated. Okay, submit answer. If you don't ask the AI to flag any key decisions, it will just go forever, right? So the reason it stopped and asking me some of the key questions is because in my rules a template, I asked the AI to flag these key decisions for social science research for me to make, right? So you see, I'm not always following the recommended options because the AI does not have the whole picture, but you do, right? You do. Okay, let's read the plan. Like I said, most of the time we'll be spend a lot of time reading the plan. Now, most of these tools, they have this comment section, right? So you can add the comment. You probably already know that. So you can highlight this and add a comment and send the feedback. Let's see. So we have these authors from OpenAlex. The goal is teaching demo that builds a co-author network from a 10% random sample. Computer centrality measures, connects them to social network theory, and draws conclusions. Output is a single Jupyter notebook for interactive teaching use. So usually it's very important to read out the context because you want to make sure that the AI and you are on the same page, right? For some jobs, if I know the context is right, the AI got the context right, I will just go with I won't read the entire kind of plan in the detail because I know the AI will be able to get that right, will be get things right. For example, write a function to analyze the centralities. You don't have to ask, right? Right now, the AI is so capable in terms of doing that. So what you really want to do, this part, the context is so important. You have to make sure that the AI and you are on the same page. So there is one point which is not on the same page with me, is the output is a single Jupyter notebook for interactive teaching use. So I will say the output should include network export that I can import to Gephi for these network boundary decisions. Age is only between pairs where both authors are in the 10% sample. It draws a boundary. This gives a focused interpretable graph for classroom use, though it will be sparser than the full neighborhood approach. That's for sure, right? But this is not only for like teaching, right? So in real analysis, in your real research, say you have 10,000 authors. For your initial analysis, you won't be able to analyze those 10,000. It's just too data intensive and not cost effective, right? So you want to just draw a 10% sample and run this entire best pipeline and see what the results are, and then iterate your pipeline, right? So you won't be able to run the pipeline once. You will run the pipeline for many times. To be cost effective and time effective, what you want to do is just use a subsample. 10% random sample is good enough for you to see some meaningful trends and results, something like that, right? So okay, so I won't change this because it's okay, but just to let you know that it's not only useful for class demo, it's also a very practical approach in real analysis. Pipeline overview, authors have a 10 sample, seed specified, so that we can replicate this anytime. Fetch works via OpenAlex API, extract coarse pairs, build networks graph, computer centrality, analyze visual conclusions, right? So one thing I think I want to read the rest because I think the AI is capable of doing that, right? So I will add one thing to this pipeline, cache the API calls so that if we break at any point, we don't need to do everything to do every call again, right? Cache. You're doing a lot of API calls. It probably take a lot of time, right? So you want to cache the results locally so you don't have to run it again. I will see the risk and mitigation here. Sparse network, that's not a problem. API failure per also caching ensures, yeah, we are retrying with backoff. Yeah, we are asking to do the caching. So we handle that. Disconnected graph, handle this, set 0 for non-largest. Yeah, this is a caveat of the algorithm itself. Some authors with no work. Log execution, report effective sample size. Log execution with no work. So it is excluding authors without any work, right? So these are isolates. Usually they are also important in network analysis. We don't want to exclude them. We want to include them as well. So we want to see what are those isolates and the percentage of isolates in the network. So if most of the people in the network they are isolated from the network, which means the network is not coherent, right? So everyone is doing their own siloed work, right? So don't drop the isolates. Include them in an analysis. They are practically and theoretically important. Okay, so we provide some feedback, send feedback, keep planning, ask you to keep planning. So it will take some time again. I want to make sure I won't break at any point. Okay, good. We are all good. Let's read them again. Read all this read the entire plan again. We have these authors, teaching demo, random sample, output a single notebook, interactive graph use. Between pairs are both authors are 10% sample. They give a focused. Yeah. These are the pipeline, OpenAlex, extract coauthor pairs, both in sample, both in graph, build network X graph, computer centrality. Build a coauthor edge list. It reminds me of another very critical. While I review this, I see another critical decision point. The AI was not asking. That is, are we calculating a directional graph, which means the direction of the link makes sense, right? The direction of the link makes sense. But this is a coauthor network, so there's no direction. If you are analyzing citation network, there will be direction. For example, I write an article, I cite the other article, right? So there's a direction about my citation. But since it is a co-author network, so we are co-authoring. It doesn't mean that I want to co-author with you or you want to co-author with me. On paper, it's equal, right? So there is no direction, but there's a weight. For example, I collaborate with you one time, right? 2 times or 3 times. Those are we call weighted network. Do you see that it is not talking about anything about the weight here, right? Oh, it has weight. Count shared papers as weight, right? Shared papers as weight. So in network analysis, compute centrality. In network analysis, when you compute centrality, depending on weighted and unweighted network, there are different ways to calculate centrality. So we want to make sure that all centrality values and stream analysis use this weight. So it is weighted analysis to be more clear rather than weighted. Add a comment. Okay, let's do another round. So this will be last step. Make sure that we have every component covered here. In your research, you probably want to go over this plan for multiple times. Make sure that everything's here. So right now we are not including references, right? So if it's for your own research, you probably have some of the references you want to add at some point as well, right? Yeah, we can do another. So for this time, this is the third one. What I'm going to add is the key references. I will add the key references to this analysis part. Ground the analysis with literature of social capital. For example, Putnam's seminal work. Right now, I'm not citing those. When you do your own research, make sure that you have the clear items cited instead of just like a very blur or very not very specific mention about Putnam's seminal work. Right. Some of you probably don't know what I'm talking about, right? But some of you probably do. So for AI, it's the same, right? Some capable AI, they know what you're talking. Some less capable AI, they won't. They don't. Okay. I still want to add another comment here too. So make distinction between bridging and bounding social capital. There are two types, theoretical types of social capitals. Bridging means some folks, they can bridge intellectuals from different communities, right? Bounding, which means in a very tight cohort, everyone is connected to everyone. Those are we call bonding social capital. Those are very different. So we do a few rounds, right? The first round, we give some feedback about methodology. Second round, we add some caveats about the weighted stuff. And it's the last round, we add some theoretical implications there. Right? Deliverable, output. I want to be lazier. Let's say also add short analysis report in LaTeX. Also write a short analysis report in LaTeX. It probably takes some time. For example, if you, oh, right, there's another point I want to add later. So retrieving information about all these authors will take a lot of time, right? Fetch works via OpenAlex API. We solve one of the cache problem. That's not a problem. So if you retrieve all the information one by one, that will be very, very time consuming. So we want to do this in parallel. Do this API call in parallel to it don't hit limit. So sometimes they will limit like every second you cannot make more than 10 calls, something like that. Okay. Anything else? Let's be nicer to the agent. Anything else in your mind? Probably we are missing. Let's read through, right? Co-author pairs. Yes, there are more information. I also want to do a regression analysis. I'm so demanding, right? So let's see. I want to do a regression analysis. I'm seriously curious whether those centralities can be predicted by any other attributes. For example, the age of references, the topic of references, right? So I want to do that regression analysis too. Analyze and visualize, right? So what I want to add here is, so this is part of your assignment as well. If you recall, in the later part of the assignment, I ask you to do some regression analysis. Regression analysis. DV is network centralities, different network centralities. IVs are what? What do you think? Citation, let's say, okay, citation, some metadata. Let's be a little bit blur here. So, but in your real research, you have a design, right? So according to theory, you think that this is the record, this variable should be predicting the network position, right? So IV is equal to some metadata of byte records, for example, citations, age, so the publication age, right? pub age, you can use shorthand as well. It understand. Publication age, what else? FWIC is a weighted metric. Control for what? Source, i.e. journals, for example, journals. Is that good enough?
A question here. So is this for whether on the author level?
Or what?
So basically all the centrality is calculated for each author in that work. The
Yeah.
roles will be author,
Yeah,
right?
yeah, yeah. You are asking the unit analysis here,
Yeah,
right?
you know that.
So the unit is an author. So everything is about the author. So you can tell for each author, the journals will be, you will see, yes, you're asking a very critical question here.
Sure.
Yes, yes. So each author, they will have their publication journals. Yes, you're right. So that's good catch here. Good. Great, you're thinking. We won't be able to control source, right? The reason is the source is at a publication level, but the network centrality values are per author, right? So there's no way we can arrange per author and the source. But what we can do is the number of source, right? The number of publications. Control for the number of sources. So, and control for the number of authors and with author fixed effect. We can add also fixed effect, right? So author has a fixed effect. So every time the author just compare to its own, to their own. Let's see how it goes. Good enough? Feel good? Okay, cool. See in the back. Let's see how it goes. Yeah, he's right. You look at that. It is right. I need to think about the data structure. The regression needs author level byte metadata from OpenAlex, right? So it captures the critical. That's why I'm telling you, you need to read as well, right? You cannot just hand it off. You need to read. Sometimes the critical decisions you have to make sure that the AI is on the same page with you. Regression figures simulation list checking environment. Sounds good. I think that's a challenging enough. That's challenging enough. So here's a question. So if it were you, how much time do you think you can finish the work plan? Let's say your advisor asks you, say, yeah, here's a plan. Do this analysis according to the plan. How much time do you think you will need? Like 2 days? Probably, I think at least 2 days. If you will need to debug, sometimes there will be a coding problem. Even with AI help you to do coding, there will be a lot of problem emerge. I think 2 days at least, right, for all this work. Okay, let's find out. We did make all this list here. So we will be seeing some files created here. Config. Okay, it has all these files pre-filled, creating all this script. Now the main notebook. This is the largest piece. I will build it section by section. Notebook structure first. There's a colossal network notebook here. Another interesting stuff, you can ask it to use sub-agents. So this is just one agent for you, right? So sometimes you can add at the end, say, use sub-agents. So this agent will start multiple agents so that they can work concurrently. So you can speed up the work process. So, but there's a cost there. So they will consume tokens faster, much faster, because it is not just one agent consume fast, but multiple agents consume tokens. So you probably will be hitting your token limit very soon, very quickly. Yeah. We can see what it is right building now. Yeah, looks right. Yeah. Let's close it and open at the very end to surprise us.
Actually, I have a question about the
Sure.
cloud code.
Sure.
So I haven't used that because I felt free subscription to any gravity. So I'm curious about what plan are you currently on for the cloud code? That is not for Python code.
Max. I'm on max.
Okay.
Yeah. Yeah.
So basically $100 amount.
Yeah. Yeah.
Okay.
In the beginning, you probably feel, wow, $100, that's a lot. But I actually did some calculation. Like in January, I probably spent about $500 on the AI stuff, including including the things I'm using, and also you need to do some coding, do some the automated coding using codebook, right? Using AI to help them do the work like that, right? So some of my research specifically focusing on AI, I need to use those API as well. So 500, I think it's already not a lot, not a lot. Then I switched to this 100 plan, so you can use it like to really help you to finish some critical work. Yeah, I'm with you. I mean, 3 months ago, I was thinking, of half a year ago, I was thinking, who is so crazy to use $100 for this stuff? But you know, I became one of them. Yeah. And it's very addictive. Once you start the plan, you cannot quit. So that's the hardest part. Yeah. It progressed to visualization. I tried to use the GPT model to help me with the notebook. I found them to be less precise. So there are always, because you know there are some metadata about the Jupyter notebook, right? So it is not always handled quite well with those GPT models. I think Claude has been doing well with all those GPT models, with all those Jupyter notebooks. So it is now on section 8, conclusions. So you see what it is building. It is using the Jupyter notebook as a backbone, right? As a backbone. It's try to build everything in the Jupyter notebook, which is great. So Jupyter notebook, that's why it is popular for social science research, is because you can do this section by section, and you can write a lot of writings within the Jupyter notebook. This is exactly my workflow while pre-AI stage, right? In the pre-AI age, what I did is first I wrote a very long notebook. So within each of the block, I have a lot of writings about the article itself, right? So what I did then later is I transcribed those writings from the Jupyter notebook to my writing. So, right? Because if you do social science analysis, especially for this empirical part, you have a lot of things that are embedded. A lot of your writings are embedded with your code, and your code is also embedded with your writing, right? For example, one of the, like I just said, just to show you, one of the how you justify the choose of one measure, you have to tie to some of the theoretical literature, right? So notebook provides you a very good environment or tool that you can embed your theoretical piece with your empirical piece, and also your empirical piece or your code with your theoretical piece as well. Updated memories. So what the agent is doing right now is went over all these kind of decisions or progress it has made, and try to update the memory about what it has done. So current coarse network analysis using OpenAlex data. Construction, this is the current work. Priority, run the Jupyter notebook, end-to-end, fetch data, build network, compute centrality, run regression. Review results, refine theoretical, compile LaTeX report with actual figures and tables, active assumptions, known risks, sparse network, FWCI may be missing for many works, reducing regression sample size. Yes, that's true. So, for example, this part, theoretically, what you have to do is how you want to treat these missing data. Are you going to use 0 for all those works without all these values, or you just drop them? If you drop them, I think that will make your sample very small, right? It depends, right? And also it give you a clue that how you want to do robustness test. For example, in the robustness test section, you want to change, or you want to entirely drop them and see how the results change. You want to replace all these missing values as 0 and see how the results change. If under different situations, different imputation strategies, your main analysis still hold, which means your analysis is robust, right? Immediate next step. Okay, you see it is start to getting information, right? You see the work here. So it start to retrieve all the information here. So many. You see all these are about the author information here. I will go to, there are already 155. Data, intermediate, works cache. You see, there are all these files here. Also meta cache, works cache, which means the article, each of the article. Each also probably will produce a lot of articles. Yes, it will probably take a lot of time. Now fetching also metadata. Also metadata complete. Check final notebook execution status. Verify all output files were generated. Let's see the output here. Figures. Oh, look at that. We already have figures. Oh, look good. That looks good. Not bad. Some centrality values, long tail, different types of centrality values, weighted degree, betweenness, cloneness, eigenvector. What's a red dash line? It's mean. Yeah, red dash line use mean. You see the mean is here. Right? It is using mean as a reference point. So mean, median. Yeah, the median is here. So the median is more useful than mean for this distribution, right? So if you look at the distribution, it's very long tail. The mean is just means nothing. So the median, which means half percent. Sometimes you want to have a finer view of this data set. You more want to see the like first quantile, second quantile, third quantile, and the fourth quantile, right? Something like or the third quantile. Degree distribution, network graph. Like produce network graph. Does it look good? Yeah, it does not look good. You see, there are a lot of loops here. Yeah, we will not use it anyway. So regression coefficients. Huh. None of those results are significant, but there's something significant here is the mean publication age will likely to predict the eigenvector centrality here, right? You see that? Yeah. Top authors radar, clonus, weighted degree, eigenvector. Yeah, not sure how this can be useful, but let's put it aside. Yeah, these are different authors, the different authors. So what you want to do is, it's useful in this way. So if an author is very capable, it should be capable on different dimensions. So the author should have the largest kind of area here. What the author, according to this figure, who is the author? This blue author. Do you know this person? Do you know this person? No? Is this a very well-known author in the research topic, on the research topic you have? Can you quickly search this person and see what kind of study he's doing or she's doing?
Which one specific?
This one, this blue author, Rita Chinchi Chang.
Rita Chang. Okay.
Yeah,
I guess I know.
you know her? Okay, is she a kind of a really?
I think she's kind of like a.
Wait a second. You are on.
Work as well.
Okay, awesome. So what this tells you is, you see all these authors, all these listed authors, they are not stranger to you. That makes sense? So you know this guy, you know these individuals, these seminal scholars here, which is give you some sense about face validity, right? It is not hallucinating anything. It gives you some face about what you are studying is does have some kind of face validity. Okay, cool, awesome. I think we probably already finished the work. Let's say models, tables. It has also tables here. Okay, that's it. Okay, the work is finished. Let's see what we got here. Everything is complete. Here's a summary of what was built and the key findings. We have all these files list here telling you what are the stuff here. Man notebook. This is have all the source you need. Key findings from the data. Network structure, centrality distribution, bounding and bridging, which we defined, right? So regression. The bibliometric predictor explains very little variance, right? So suggesting that the network position in this sample subgraph is not strongly predicted by citations, publication age, FWCI, or productivity. The only marginal significant model is closeness. This is expected given the sparse sample-only network boundary. Yeah. That's it. That's a very draft version, right? So if you want to really get some thing that is substantive, you have to spend more time as well, right? So you see, first, there are things you notice, right? First is AI is powerful, right? It's powerful. Second, it doesn't mean that you can be replaced, right? You still make a lot of key decision here. And if you keep working on this, you need to make more nuanced decision. More nuanced decision. For example, like I said, the FCI, there are a lot of missing values, right? How you are going to handle those missing values, run robustness test or not, right? Therefore, the experience here is just so important. I said a lot of stuff, I know them, so I ask for, right? The reason I know them because I have the experience. Right? If you've never done this research like this, you don't know what you are going to ask for. That makes sense? So you don't know what to ask. You don't know what you don't know. That's a problem here. So I think part of the training here, part of the the education we are doing here is to make you aware about a lot of expertise rather than you have to do those in very detail, right? So that's one of the reasons we have assignment asking you to analyze those empirical studies, right? So those empirical studies, already published empirical studies, they are very good in terms of giving you good examples. I learned all this experience in a hard way. So before the AI age, I read those papers, I get paper rejected, and then I revise. I have the I have the kind of a battle with all those reviewers. So I learn all those experience in the hard way. You don't have to. You will have to in the future. Right? There's no easy way to learn things easily, right? So but one of the takeaway is very clear that you need to be experienced. So everything you need to learn have to make you an experienced researcher with insights. With insights, you don't have to know a lot of technical details. For example, how to run regression code, how to run like those fixed effect analysis by hand. You don't have to know that details. All this AI can help you do that. Even like before AI time, while I was doing that, while I was doing all this research, I have to handle those by hand, right? For example, the imputation, I have to write the code for imputation purely by hand. But now these AI can help you do that. But it does not replace the nuanced decisions you are expected to make. Yeah, you expected to make. It makes sense? Yeah, cool. So that's why I think the AI will help you do the work. And I'm not shy telling people that I'm using AI to do my research because I'm confident that even I'm using AI, I putting in a lot of substantive knowledge, insights, and domain knowledge into this workflow. So that's kind of I'm not just letting AI do everything for me and just use what it is, right? So it's you have more time to pursue what is really important in social science research. That is about theory, about your quality of your work, about the insights, about what matters to the world, the phenomena, or the research questions, the design of your research, right? Those things. You have more time focusing on those stuff rather than checking Stack Overflow, right? So in the pre-AI age, I every day I check Stack Overflow for hours and hours. But now I think I rarely check Stack Overflow. Yeah. So it saves your time and you can really invest your time in the proportion that matters for social science research. Any questions? Oh yeah, one thing. Let me see what the report look like. We ask it to generate a report, right? Do you still recall that? Let's compile this report and see what it look like. Okay, it's here. Causal network analysis, centrality, social capital, and the scholarly side collaboration. Yeah, this is a very, very AI language because it has no logic here. It just list everything here, right? Pretend to be good, but it does not have a logic. It does not have a soul, right? They say that. It just itemize everything here. So what's the point? If I read the paper, I read the title, so I will ask you, what's the point? What's the point of this article? You have to tell us the point. What's your takeaway, right? Your theme, your topic sentence. There's no such thing because there's no soul here, right? You have to give the soul to the paper. So this report analyze, etc. We'll go over introduction. Okay, it hallucinate a lot of this article. Some of the article, I think the Panans article, it's I know this article, I know this, I know this, I know this is the real. But sometimes you don't know, right? So I again never use the article AI give to you. Data methods, data source sampling, centrality measures, robustness analysis, results. It's very dry, right? It's very dry. Centrality distribution, centrality correlations. It looks fancy. Discussion, bounding, isolates absence of social capital, isolates and the absence of social capital. Almost it's very similar to what we told it to do, right? So the only soul this paper or this manuscript has is what we told the AI to have, right? So limitations and some references here. Oh, I don't think this, let me double check. I think the year probably is not right. Okay. Oh, it's 1992. The year is right. Some other references. This one is very classic. I know this article. These are all safe, very safe articles. Centrality in social networks, conceptual clarification, social networks. That's right. Yeah. Anyway, just don't take it seriously. Don't take these references seriously. Even they get it right, think it has a chance by chance. It's just it has a high chance they get it right. So never trust the references the AI gave you. All good? Any other questions? Okay. We ran out of time a little bit. Let's pause a little bit. The next section, we will use the Gephi to do some visualization by ourselves rather than just use what it is producing here. Okay, let me pause the recording here.